everything is made of chemicals. And when some chemicals get together, they react. Now that's a chemical reaction. Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy. Science rules. Bill Nye the Science Guy. Inertia is a property of matter.
Bill Nye the Science Guy.
T-7 seconds. Bill Nye the Science Guy. Brought to you by chemical reactions. They're a blast! Did you know that everything is made of chemicals? And chemicals can react to form new chemicals. The TV you're watching, the clothes you're wearing, and the food you eat are all chemicals. So is Senor Iguana. Now, sometimes chemicals react with each other to make new chemicals. That's what happens when you see metal rust, or you hear your stomach growl. Or maybe you've just seen a candle burning. They're all chemical reactions. Now, chemical reactions happen when the electrons, which are in everything, hook together. Now, here's a chemical you may have heard of. It's called H2O. You know what that is? That's right, it's water. Now, water is 2 parts H and 1 part O. Now, look, we're running electricity through the water, and these bubbles are forming. These are 2 gases. One of them is H, and the other is O. One of them is hydrogen, and the other is oxygen. And look, there's twice as much hydrogen as oxygen. H2O. Isn't that cool? Now, oxygen's in the air we breathe. It's what makes iron rust, makes our blood turn red. Now, right here, we have a piece of iron, which is steel wool, and we're going to run some electrons through it and make it react with the oxygen in the air. It's pretty dramatic. Yeah, see how it glows orange? Yeah, that's fine. Glowing pretty good. But over here, we have a plastic chamber that's full of oxygen and another piece of steel wool. Now watch what happens now. Pretty cool. See all the energy that's given off? And the energy's given off because the electrons are recombining with other electrons, making a chemical reaction. So, in this reaction, energy is being given off. And in this reaction, we ran energy through the water, and it separated into hydrogen and oxygen. Now, what would happen if we let these two recombine? We should get water again, right? But we should also get a little energy. Well, we can do that. Because in this balloon, we have hydrogen and oxygen mixed together. And when they recombine, we'll get just a little bit of water vapor, which will end up in the room someplace. And we should get a lot of energy. You ready? 3, 2, 1! Now that's a chemical reaction.
Hi, I'm Sinbad, and I'm made of chemicals.
Hey, Science Guy, I'm made of chemicals. Got a penny? Then do a chemical reaction. Put some pennies in a jar. Add vinegar. And a tablespoon of salt. Shake the jar. What happens to the pennies? Try it.
Okay.
I said try it.
Okay.
Hey, try it. The vinegar and salt react to strip away the grind from the copper of the pennies. It's science.
Car engines and motorcycle engines are controlled by chemical reactions. They combine gasoline with oxygen in the air in small, controlled explosions. Listen up! Don't try this at home without adult supervision! This top hat is made of chemicals and is held together by chemical bonds. These torches are made of chemicals. Even I am made of chemicals. Just about everything is made of chemicals. Candace the Science Gal.
Do you know that fire is a chemical reaction? Well, it is. Fire is what you get when chemicals and things like paper and wood react with the chemical oxygen in the air. You know, if this were Cameron Labs, we wouldn't be having this problem.
Hey, Candace. Nice tie.
Thanks.
Come on in.
Hey, I was just explaining fire.
You mean like when chemicals mix with oxygen in the air usually give off heat?
Wow, this is pretty cool. It's like a big swirling chemical reaction.
Yeah, we call it the tornado of fire.
Hey, you know what else is a really cool chemical reaction? The carbon dioxide fire extinguisher.
There's one over there.
Thanks, Rule. You can make the fire extinguisher. A real one. It's easy. Just take a large plastic container with a tight-fitting lid. Poke a hole in the lid. You might need an adult to help you.
Guess that's me.
Yeah, sure, Bill. Yeah.
Heat a nail up over a candle. When it's warm enough, gently poke the nail through the lid. There, nice clean hole.
Thanks.
You're welcome.
We're wearing safety goggles because we always do when we're messing with chemicals. First, you put in some baking soda. And add some water. Make sure it's thick. Pour some vinegar into the smaller container. Now, place the smaller container into the large jar. Like this. Screw on the lid. Put a straw in the hole. And go find a fire. When you mix vinegar and baking soda together, you get carbon dioxide gas. Carbon dioxide gas pushes the water out, which makes the fire go out.
Thanks.
Cool. Very cool. And now for a really big chemical reaction.
Hi, please consider the following. I'd like to talk about two poisons that we can't live without. I'm talking about sodium and chlorine. If you breathe just a little bit of chlorine gas, it would do you in. You'd be out of here. You'd get flatlined, just like that. You know what I'm saying? And watch what happens when we put just a small piece of sodium in water. Water like you might have on the roof of your mouth. It is pretty cool. These two chemicals, when they're separate, are dangerous. But when they're chemically bonded together, the pull of their electrons is so strong that they form a whole new substance, a whole new chemical called sodium chloride. Sodium chloride. Sodium chloride. Now, another name for sodium chloride? Salt. 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 Now, our blood is salt water. Our tears and sweat are salty, and so are potato chips. Thanks for joining me on Consider the Following.
The Reactors, crime-fighting chemists in a series with more Brownian motion than oil and H2O. Thrilled to their molecular mastery. Cheer their combustive combinations and bond like you've never bonded before. The Reactors, a crime-fighting quartet dedicated to better catching through chemicals. Catch them on the Bill Nye the Science Guy television network.
My name is Phil Grucci, and I'm a member of the 5th generation of pyrotechnicians in our family. Pyrotechnicians is the name or the title given to people that manufacture and use fireworks or any type of pyrotechnics. Pyrotechnics is an art form that involves a complete understanding of how chemicals and certain metals will react to each other when they're blended together. Every time you see a firework burst in the sky in its beautiful colors, what you're really seeing is a chemical reaction. The metals will create the twinkle, where the salts will create the colors. Some of the metals and the salts combined will create a red with a twinkling color added to it. When we mix strontiums, for instance, it'll give you yellows. When you take a copper metal and burn it at a certain temperature, it'll give you blue colors. Aluminum gives you your white. Barium combined will give you your bright white as you see daylight. Powdered aluminum with an oxidizer will create your bang, the bang that you hear in the sky. The safety is very important to realize that it's taking us 5 generations to perfect what we do. It's not something to take lightly. It's not something to experiment with. So it's not something to play with at home.
This experiment's a classic. It's a classic because it's cool. You need a balloon and a soft drink bottle. The bottle can be plastic or glass. I like plastic better because you can do this. Fill the bottle with about 200 milliliters of vinegar. Then put about 25 milliliters of baking soda in the balloon. If you spill some, that's okay. It doesn't make that much of a difference. It's just baking soda. Next, carefully put the balloon on top of the bottle. I like to hold one side with my thumb and pull the rest of the balloon on. Now, tip the balloon straight up and shake the powder down into the liquid. Look! Carbon dioxide gas is forming and it's filling up the balloon. You know what else? It's a little warm. That's because we're releasing energy. It's a classic. It's cool. Welcome to this week's edition of Better Eating Through Kitchen Chemistry with your hostess, Vivian Cupcake.
Hello, I'm ever so glad you could join us today, because the kitchen is exactly like a chemical laboratory. It's filled with wonderful chemicals. The cabinets are made of chemicals, the countertops made of chemicals, all the appliances are made of wonderful chemicals. And I've got all the chemicals we need to make a delicious chocolate cake. First thing we need to do is add the sugar, some butter. Get the butter in here. An egg is a special substance filled with chemicals called protein. I'm going to add some flour and some water. Water's the most important chemical there is. Oh goodness, it's awfully white. We forgot to add the cocoa. That's the flavor chemical. Baking soda. Well, if we add some of the water that I just added and some heat, we'll make a chemical reaction and form little bubbles called carbon dioxide. Those carbon dioxide bubbles will rush up out of the cake and make the cake all cakey and delicious. I can't wait to see what happens. Mix it up, mix it up. Mixing and mixing and mixing some more.
A public service announcement from the chemical people.
Hello. I'm not a chemist, but I am playing one on TV. Did you know that there are 92 elements that make up everything we know and love? Things that you and I use each and every day of our lives. Can you think of something you know and love that isn't a chemical? I don't think so.
Don't even think about trying this at home. A chemical reaction happens when chemicals combine to form a new substance. This is a chemical reaction.
Yeah, let's go to the hot water. Yesterday we shot the pictures, and today we're developing it so that the negatives will come out so you can see them, and then we're going to print them into pictures. Paper, but normal light makes it turn out black. I'm putting the picture into the developer, which is a chemical that makes the image appear, and it reacts to the emulsion on the paper.
The stopper stops all the chemicals from the developer.
And now into the picture, which makes the image permanent. That's how you do it.
Mixing and mixing and mixing some more. Still mixing.
And now for another really big chemical reaction. Have you ever heard of the Nobel Prize? The Nobel Prize is awarded to people who have done great works for humanity. There's Nobel Prizes in art and for peace and for science. See, Alfred Nobel was a Swedish chemist who invented dynamite. Now, dynamite makes it a lot easier to move a lot of dirt around. A lot easier than you can move it around with a shovel. Anyway, dynamite made Alfred Nobel rich. Fabulously rich. He became so rich that he arranged that every year, money will be given away to people who win a Nobel Prize. Now, everybody who wins a Nobel Prize gets about $1 million. That's not bad. It's all from a chemical reaction. Dynamite. Dynamite was invented in Sweden.
Sweden is also known for smorgasbords, Vikings, and speaking Swedish.
When an athlete gets an injury, she may use one of these cold packs. Inside are two chemicals. When you break the plastic that separates them, the chemicals mix. The chemical reaction takes up more energy than it gives off. So the cold pack gets cold very fast. Woo! Now that's chemistry.
I think we're ready. I'm just going to take my batter, which is all liquidy now, and pour it into our cake pan. Ooh, this will be yummy. Now I'm going to take our cake and pop it in the oven for some heat. Set it in the oven for about 1 hour. It's done! Oh, what a lovely chemical reaction. It's perfect, just perfect. Isn't chemistry marvelous?
Scientists have kept track of what fundamental chemicals, what elements behave in what ways, and we've listed them on something called the periodic table of the elements. There's only 92 naturally occurring elements, but if you think about it, you can think of a lot more than 92 things. They're all made of the elements listed on this table. Like, for example, calcium is in milk, and sodium, it's in salt, and potassium, it's in bananas. And calcium, sodium, and potassium all behave in much the same way in chemical reactions. So they're grouped together on the periodic table. The same is true of helium and neon, which are used to make this laser light. The periodic table tells us a lot about chemicals. Like, for example, banana milkshakes have a lot of milk and bananas. It's a lot of calcium and potassium. Now that's chemistry. The periodic table. I never leave home without it.
Our attorney has advised us. Please do not try this without adult supervision. Chemicals in these torches are combining with chemicals in the air because of their electrons.
And now for yet another really big chemical reaction.
Well, that's our show. Chemical reactions can be pretty fun. Let's let her rip.
Produced in association with the National Science Foundation.
Chemical reactions are pretty fun. Let's let her rip. Chemical reactions can make gas. Expanding gas can make things